Deep ebony skin. This shade represents the peak of human melanin concentration, an evolutionary masterpiece created to withstand the planet's harshest sun. Melanin is the pigment responsible for skin color, but more importantly, it is the body's natural shield against ultraviolet radiation. This tone emerged in regions such as equatorial Africa, where UV exposure is intense year-round. In these areas, the skin produced melanin in extraordinary amounts, forming a deep ebony color that can even carry cool or bluish undertones. This heavy pigmentation protects the genetic material inside skin cells, dramatically reducing mutation risks and lowering the chances of sun-induced cancers. In environments where sunlight was constant and severe, this wasn't just helpful, it was essential for survival. Beyond defense, this pigmentation displays exceptional durability against prolonged exposure, maintaining both skin health and structural integrity. Groups in East Africa, like many Nilotic populations, showcase this phenotype most prominently. The tone reflects thousands of years of adaptation to extreme sunlight, high terrains, and dietary variations that influenced melanin expression. While visually striking, its significance is evolutionary precision. Maximum solar protection combined with a stable relationship between the skin and its surrounding environment. Rich, dark brown skin. This tone contains slightly less melanin than ebony, yet it still offers significant protection from ultraviolet rays. It presents as a rich brown with warm, golden, or reddish undertones, and appears frequently in populations from West Africa and regions of South Asia. The high melanin content guards the skin from UV damage and reduces the risk of sunlight-triggered mutations. At the same time, the slightly lower density, compared to the darkest tones, enhances the body's ability to produce vitamin D, creating an advantage in regions where sunlight is strong but fluctuates due to humidity or seasonal shifts. The benefit of this tone lies in its equilibrium between resilience and adaptability. It provides the strength required to endure high UV exposure, while responding more efficiently to brown skin, a highly adaptable evolutionary trait across equatorial. Over countless generations, the blend of strong protection and moderate vitamin D production shaped a tone that was both versatile and vital for long-term survival. Mahogany brown skin. This tone shows a deep brown shade with coppery or reddish undertones. It evolved among populations in tropical and subtropical areas where sunlight remains strong but less extreme than directly on the equator. The melanin concentration is high enough to defend against harmful UV radiation, reducing the risk of rapid burning and long-term damage. Yet, it is not as dense as the darkest tones, which allows more efficient vitamin D synthesis when sunlight is present, but not always intense. This fine evolutionary calibration allowed mahogany-toned populations to prosper in diverse environments across Melanesia, South Asia, and regions shaped by centuries of migration. Its greatest advantage is versatility. It provides dependable UV resistance while enabling the body to respond dynamically to changing levels of sun exposure. Individuals with this tone often tan smoothly and quickly, demonstrating the skin's ability to adjust to varied conditions. Evolutionarily, it offered stronger defense than lighter tones in tropical zones, while still maintaining better nutrient absorption than the deepest tones under less predictable sunlight.
The result is a pigmentation type precisely tuned for resilience, adaptability, and mobility across wide landscapes. Light golden brown skin. This tone appears lighter in shade with warm, golden or sun-kissed undertones. It developed in populations from the Mediterranean, North Africa, and parts of South Asia, regions where sunlight is abundant but moderated by changing seasons. The melanin level offers protection against burning while supporting efficient vitamin D synthesis, which is essential for bone strength and immune support. This balance between shielding and nutrient absorption represents an evolutionary response to climates with both high sunshine and periods of reduced light. A key feature of this tone is how easily it tans, forming a protective layer during high exposure while minimizing the risk of UV damage. Over time, this ability granted an advantage in areas with hot summers and cooler winters. Light golden brown skin allowed people to stay protected during intense sun, yet remained efficient at nutrient production when sunlight diminished. It showcases how subtle melanin adjustments create skin that is durable and responsive across contrasting seasons. Olive-toned skin. Olive skin is marked by a neutral base blended with greenish, yellow, or grayish undertones, giving it a unique appearance that often shifts depending on lighting. This adaptation appears in southern Europe, the Middle East, North Africa, and certain Andean populations.
The melanin level is moderate, offering a compromise between strong sun protection and effective vitamin D synthesis during colder or cloudy seasons. This level of pigmentation shields the skin from UV radiation, while remaining sensitive enough to absorb sunlight when solar intensity is low. One fascinating characteristic of olive skin is its camouflage effect. It may appear darker in sunlight and lighter in shade, which helps prevent overexposure and supports consistent vitamin D levels. Many populations with olive tones historically lived along migration crossroads, making this skin type a reflection of both adaptation and diverse ancestries. Evolutionarily, olive skin represents flexibility, robust enough to handle strong sun, yet optimized for fluctuating climates where hot and cold cycles alternate throughout the year. Warm beige skin. Warm beige falls between fair and light brown, featuring a neutral undertone that may lean pink, golden, or gray, depending on ancestry. It is typical in parts of southern and eastern Europe, Latin America, and West Asia. The melanin level is lower than that of olive skin, but higher than the fairest complexions, creating a balanced level of protection. This tone developed in regions with pronounced seasonal variation, where populations experienced long periods of weak sunlight and occasional bursts of stronger summer UV. Its strength lies in adaptability. Warm beige skin tans easily, forming a protective layer during sunny months, while in dimmer seasons it absorbs UV light efficiently for vitamin D production. This reduced the risk of deficiency-related illnesses like rickets, especially in regions farther from the equator. Over centuries, this tone became widespread among migrating groups moving between northern and southern climates, serving as both an evolutionary response and a marker of historical movement. Fair light skin. Fair light skin contains relatively low melanin, giving it a pale beige or lightly pink tone. It evolved primarily in Central and Northern Europe, where sunlight is limited for much of the year. With less melanin blocking UV rays, the skin absorbs sunlight more efficiently, accelerating vitamin D production. In regions with long, dim winters and minimal sunlight, this capability was crucial for maintaining bone health and preventing deficiency-related diseases. The evolutionary advantage of fair light skin lies not in protection, but in efficiency. Although it burns easily under strong sunlight, it maximizes vitamin D production in low-light environments. This ensured survival in northern climates, where abundant melanin would have hindered nutrient absorption. Over generations, this pigmentation allowed communities in cold, low-sun regions to thrive, showing how the body adjusts to match environmental light levels. Very fair skin. Very fair skin has the lowest melanin concentration of all human skin types. It appears milky white or almost translucent, often showing visible veins. This tone developed in Northern Europe, especially among populations in Ireland, Scandinavia, and the Baltic areas, where sunlight is scarce for most of the year. In these environments, heavy melanin would have blocked what little UV radiation existed. With minimal pigmentation, very fair skin absorbs maximum sunlight, enabling high vitamin D production even under weak solar conditions. This reduced the risk of bone-softening diseases such as rickets. Its evolutionary strength lies in extreme efficiency. Although prone to burning in intense sun, this vulnerability wasn't an issue in regions where UV exposure was naturally low. Instead, it became a survival asset, ensuring that populations could convert minimal sunlight into essential nutrients necessary for health and reproductive success. This adaptation reflects how human groups fine-tuned pigmentation to thrive in cold climates shaped by glacial history. Don't subscribe and understand.